Okay, so today I'm gonna be solving yesterday Leetcode daily problem, pyramid transition matrix. So the idea that I have to how to solve this problem. So like, what's given? The bottom line is given, and then allowed combinations are also given. And I need to basically figure out if I can build the pyramid up to the top by using only allowed combinations. And the combinations is like giving like BCC, let's say first two letters is the bottom and the last one is the top. So like here there's BCC and the next one is CDE and the next one gonna be CEA, this one. So the pyramid can be built in this case and I should return true. In case like pyramid cannot be built, I should return false. So my idea is like pretty simple. It's just build up the backtracking algorithm and how I gonna solve it. So first of all, I'll build a map of valid combinations, and like the key gonna be, let's say, for BCC, or let's say for BCC, or like for CDE. For CDE, it should be the key CD, and then the value should be E. And then I'm gonna start going through the bottom line and start moving I. And initial I gonna be at 0, and then I'm gonna take like this two symbols at 0 and 1 and try to find the value in the map for, say, character 1 and character 0 and character 1. And if I can find it, though there might be like multiple values for the same key, let's say this is not visible, but sometimes it can be like allowed combination CDE and CDA. In this case, I'm gonna have the key for the CD. I'm gonna have this list of values is gonna be E and then A. And then in case there are two possibilities, I need to explore both of them. So I'll branch there and like do BT iteration for every kind of pair, and then I'm gonna move to next pair, move to next pair, move to next pair, etc., 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 and the result until the last pair, and the result gonna be basically if this is the size of n, the next one gonna be size of n minus 1, and then there might be like multiple possible strings of the n minus 1 level, and then I can build n minus 2 level, and then n minus 3, and then so on and so forth until the last level, if it's possible. And if it's possible, I return back true. And if it's somewhere this I cannot find the value for the key, I'm gonna stop and return false. So the first iteration, build a map. First item of the plan, build the map of valid combinations. And the second one, do BT for bottom line. Build current line. And then the third one, based on current line call bt for the next for the current line current line, and that's gonna be the sketch for the solution. So let's say I first of all I built this map, so I'm gonna go map is equal default dictionary and then the list. Then for a in allowed, I'll do map and then a 0 up to 2 dot append, and then I want to append a2, and then I'll go and so I'll have this internal function called, let's say, pyramid it's called transition, and then I'm gonna have here bottom as a list of strings, and then I'll have this map as a dictionary, and then the dictionary that has a string as a key and then the string as a value, and this one should return true or false, so it's gonna be bool. And then I'm gonna have the current level, I think just current equals list, and then I'm gonna call, I'll have bt, and then I'm gonna call so bt at the index I int, and then current as a list of string, and then bottom as a list of string, and then map as a dictionary string, and then I'm gonna also return bool. So I'll do, so if the pyramid transition, so if the so here bt so I can call bt at 0, and then current, and then bottom, and then m, and then I'm gonna have the result equals this one, and then I'm gonna return result, and then for the bt I'm gonna so in case if I is equal current, so let's list, or like len bottom -1. Then I'm gonna check if current, if len of the current one is equal if len of current is equal 1, I'll return true. Otherwise, I'll call pyramid transition for the current, and then for the dictionary, and then I'll do this one. And for the BT iteration, I'm gonna check if, so I'm gonna go if the key gonna be bottom I and then I plus 2, and then I'm gonna join it. Join this one, and then I'm gonna go if that get key is none, I'm gonna return false. Otherwise, for the character in key, I'm gonna go car append character, and then I go bt I plus 1 current bottom and then I'm gonna have this result. So in the end, I'm gonna have this current.pop, and then I'll say res equals this one, and then if res, then I'm gonna return true. Else return false, something like this. And then for the pyramid transition, I'm gonna go call initially pyramid transition for the initial bottom line, and then for the dictionary, and then I want to return this result. So here I want to return pyramid rendition result. Yeah, something like this. So let me run it and figure out if it's gonna be successful. Okay, let's submit. Not like as good as I expected, but I can like basically improve it a little bit. If I add the cache, so if I add, say I'm gonna have cache equals dictionary, and then I'm gonna accept cache. Let's call it mem, and then here mem, and then mem gonna have type dictionary, and then string as a key, and then boolean as a result. And then I'm gonna have the same kind of here. And then I'm gonna pass it everywhere. Yeah. And then here I'm gonna check memization, and then here be mem, and then here before calling this for the bottom. So if let's say key is equal this one join bottom, and then I'll do key, and then I'll check if cache, like if mem key get key is not known, I'm gonna return mem key, and then otherwise I wanna insert this result into mem key. Mem key is equal result. Yeah, let me run it and see how it's gonna go. Yeah, so this one boosted performance quite a bit from like lower percentile to higher percentile. Yeah, so that's gonna be it. The solution for the yesterday daily problem for the Leetcode. Okay.